Hello students, now we will discuss analog to digital conversion or A to D conversion. It is the exact reverse process of digital to analog conversion, that is D to A converters. In analog to digital converters, input is in the form of analog and you will get output as a digital form or in the form of zeros or ones. Analog to digital converter produces a digital output that is proportional to the value of the input analog signal. When an analog signal is processed by a digital system, ADC is used to convert the analog voltage to a digital form suitable for processing by a digital system. What is analog to digital conversion? Analog to digital converter is an electronic device that converts a continuous analog input signal to discrete digital numbers. Analog input signal to discrete digital numbers, that is in binary. Analog real world signals that contain noise, continuous in time. Digital signal, discrete in time and value, binary digits that contain values 0 or 1. What is analog to digital conversion? You will see in the picture, the whatever input is there, that is in the form of continuous. The analog signal is continuous in time and value, and what you will get output in the form of digital, that is the digital signal is discrete in time and value. You can easily identify or easily understand how the digital analog to digital conversion is done using this slide. Okay. Next, why analog to digital conversion or A to D conversion is important. All microcontrollers store information using digital logic. All microcontroller stores information using digital logic. Compress information to digital form for efficient storage. Medium for storing digital data is more robust. Digital data transfer is more efficient. Digital data is easily reproducible. Provides a link between real world signals and data storage. Provides a link between real world signals and data storage. How ADC works? 3 stages. ADC will work in 3 stages: sampling, quantizing, encoding. Sampling, quantizing, encoding. Analog signal is in the form of input, and input is in the form of analog. Now sampling is done, quantizing is done, and encoding. You can see above quantized signal. Now you will get digital data as output in the form of zeros and ones. Now sampling, what do you mean by sampling? In sampling, the amplitude of the analog signal is sampled regularly at uniform intervals, and each sample is quantized to the nearest value within a range of digital steps. And quantizing, ADC's sample the input signal and then apply a process called quantization. The quantized forms of these samples are then converted to binary digits and are outputted in the form of zeros and ones or ones and zeros. This is, see how quantizing is done. You have for example, you have a 0 to 10 signals, separate them into a set of discrete states with 1.2 volt increments. This is called, or this slide shows how quantizing is done. Next, quantizing a number of possible states that the converter can output is 2n is equal to 2 raised to small n, where small n is the number of bits in the A to D converter. Example, for a 3-bit A to D converter, n is equal to 2 raised to 3 equal to 8. Analog quantization size Q is equal to V max minus V minimum upon n. V max minus V minimum upon n, that is equal to 10 volt minus 0 volt upon 8. That is 8 is capital N number of steps equal to 1.25 volt. 1.25 volt. Now N coding. Here we assign the digital value or binary number to each state for the computer to read. That is output states 0, 1, 2, 0, 1, 2, 3 like 7, and output binary 0, 0, 0 to 1, 1, 1, that is 0 to 7. Now we will see types of ADC. Now we will see types of ADC. Flash type, dual slope, successive approximation. First we will see what? Dual slope ADC. We will see dual slope ADC. Here you can see the block diagram of dual slope ADC. It consists analog input, V reference, and then control switch, then integrator, comparator, AND gate, and control unit, counter, flip-flops, and 7-segment decoder and 7-segment display. The sampled signal charges a capacitor for a fixed amount of time. By integrating over a time, noise integrates out of the conversion. You can see here dual slope. For one slope time is fixed, for another slope V reference or means voltage is fixed. The ADC discharges the capacitor at a fixed rate with a counter counts the ADC's output bits. A longer discharge time results in higher count. A longer discharge time results in a higher count. Then dual slope ADC advantages. Input signal is averaged, greater noise immunity than other ADC types, high accuracy, low cost. Offset correction can be introduced by a relatively simple circuit. Offset conversion can be introduced by a relatively simple circuit, facilitating auto zeroing. Then what are the disadvantages of dual slope ADC? Long conversion time as compared with other ADCs. High precision external components required to achieve accuracy. Now we will discuss successive approximation type A to D converter or SAR ADC. Here you can see in the block diagram, analog input is fed to comparator and another one input of the comparator is output of DAC. And control logic, that is successive approximation register, it is having a three outputs: clock, start, end of conversation. Output register, that is output register which is input to the DAC, and you can take digital output from that output register which is having LSB and MSB. Conversation process. Step 1. The MSB is initially set to 1 with a remaining 3 bits set as 0. The digital equivalent is compared with the unknown analog input voltage. Step 2. If the analog input voltage is higher than the digital equivalent, the MSB is retained as 1 and second MSB is set to 1. Otherwise, the MSB is reset to 0 and the second MSB is set to 1. Otherwise, the MSB is set to 0 and second MSB is set to 1. Conversation process. Step 3. Comparison is made as given in step 1 to decide whether to retain or reset the second MSB. The third MSB is set to 1 and the operation is repeated down to LSB, and by this time the converted digital value is available in successive approximation register. Here you can see successive approximation tree, how the unknown analog value is converted into or known digital output. So each unknown analog voltage is compared with known voltage, then weighing system, continuously unknown voltage is measured with a known voltage. Then what are the advantages of successive approximation ADC? The conversion time is equal to the n clock cycle period for an n bit ADC. Conversion time is constant and independent of the amplitude of analog signal. Here conversion time is constant and independent of the amplitude of analog signal. Then what is the disadvantages with the SAR? Circuit is complex. The conversion time is more as compared to flash type ADC. The conversion time is more as compared to flash type ADC. Now we can see comparison between successive approximation and dual slope. Here we can see parameter. That parameter is conversion time. For successive approximation less, dual slope more. Parameter is speed. Successive approximation greater speed, dual slope lesser speed. Accuracy of conversion for successive approximation less accurate, dual slope more accurate. Compared to cost parameter, more cost is for successive approximation, less cost is for dual slope. Applications in data acquisition system, in applications where accuracy is required. Now we will see specifications of ADC. In that, first one is resolution. Resolution of the ADC is the change in voltage input necessary for a 1 bit change in output. It can also be expressed as percentage. Next specification is accuracy. The accuracy of A to D conversion is limited by the plus or minus half LSB due to quantization error and the other errors of the system. It is the maximum deviation of digital input from the ideal linear reference line. Ideally, it approaches plus or minus half LSB. Next specification is speed. It can be defined in two ways, that is either the time necessary to do one conversion or time between successive conversion at the highest rate possible. Second definition is speed depends on the setting time of components and the speed of the logic. Now you can see the pin configuration of ADC 0804 or 0808 or 0809. All are same indication, or 0809 or 0804, all three are same. So this pin configuration is very important for 5 marks.